Just one final note on minerals and economics. Many times companies say they need these tax subsidies that are given to them to keep the prices low for consumers, that the consumers could not be able to handle the real cost of the mining these ores, and prices would shoot up tremendously if we think about what the price of a car or electronics would be if we actually had to pay for those costs. This is a similar argument that we hear all the time for why we can't clean up our pollution. It's a similar argument across the board. So, do we believe that or not? If not, the companies would just say we will move to another country where we can be more profitable and extract the minerals from there. You kind of wonder what cost to the people in that area as well, though. So, what can we do about our use of minerals and the growing lack of minerals, since they are a finite resource? One thing we're looking at are new sources and where we can obtain the minerals that we need by newer technology. One of these is by taking those low-grade ores, those that have just a smaller amount of usable material in them, and come up with new technology to extract it and to process it so that it does become profitable to us. This typically does tend to increase cost because there's more that has to be done to the ore. And this kind of follows along the whole second law of thermodynamics, that you always move from useful to a less useful form. So it's going to take a lot more energy to do this. Another problem with this is, again, many of these mines in the US are in the western states, and the use of fresh water to process these is a real concern. Another pretty unique way of getting some minerals is by a process called biomining. This is still something that is in the experimental stages. This is when microorganisms actually break down the rock and extract the minerals. There is certainly way less air pollution. It leaves the environment undisturbed. There's less water pollution. The main problem with this is it's going to take a long time to do this with our current technology, but this is being researched and still in development, and we're looking at this through some different ways of genetically engineering microorganisms to do this process for us. Another source of minerals is the ocean. For a long time we've known there have been great mineral reserves, but they are at the ocean floor at depths that we cannot safely get to, or their concentration is too low. We could increase this by looking at some offshore minerals, things like this. But these are some other steps we're taking, is looking at the ocean for a new source of minerals. Along with the ocean is the hydrothermal vents. Again, this is also usually very, very mineral rich because you're getting the minerals that might be soluble at those high temperatures because of the hydrothermal activity. As they come up through the ocean and then they reach that colder water, then they tend to settle out. And these areas are usually very rich in copper and lead and zinc and aluminum, and silver and gold. It's really, though, currently too expensive to be profitable. We kind of have the technology, but it's still just too expensive for us to use fully. Another unique approach is just to have material substitutes or mineral substitutes. We've talked about lots of revolutions lately with the Green Revolution and so forth, but there is a material science revolution. If you think about what packaging used to be, is in the 1950s, pretty much everything was in a steel or a tin or a glass container. And if you go to the grocery store today, what are things packaged in? Plastic, 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 right? So we're looking at plastics, things like silicon and ceramics also being replacement for metals. Even your communications. Communication used to all be pretty much conducted through copper and aluminum wires. How do you get your television signals now? Through a fiber optic glass cable. The fiber optic is made of a silicon dioxide. It's just spun glass, and that's how it transmits all that information. Carbon fiber is a really growing field, used in everything from skis and snowboards to police vests and military protection, just a wide range of things. It's really, really strong. It's copper, so it's looking at a lot of replacement using carbon fiber materials, and that gets into a field called nanotechnology as well. You may have heard some about that. Some minerals, though, we just can't replace. Something like platinum, it's used as a catalyst in many chemical reactions, and so there's really no substitute for it. It needs, we need to have that material, so we have to find more sources for platinum whenever we run out. Another thing we can do to decrease our need to be mining minerals is to recycle and reuse. Aluminum is probably the easiest material to recycle. It makes 95% less air pollution, 97% less water pollution, uses 95% less energy than mining and processing aluminum ore. If you don't recycle, you need to be recycling every single thing that you possibly can. It decreases our use and our waste of resources in multiple levels, and again, less air pollution, water pollution, just something we need to do more of. And companies are realizing that this is important too. One company known as the Minnesota Mining and Manufacturing Corporation, they started a program way back in 1975 to try to use fewer hazardous materials, reduce waste, recycle, and they estimate that they've saved over $1.2 billion in waste disposal and material cost. You may know that company as 3M, and it's maybe never thought about them, the makers of sticky notes and tapes and all sorts of things, that they are actually a mining company, and they have produced quite a few products that we probably couldn't live without these days, and they're also a very environmentally friendly company.